Quadratic equations. What are those? Alright, a quadratic equation is any equation which has the form ax squared plus bx plus c equals 0, where x is an unknown, and a, b, and c are known constants. The defining reason why this sort of equation is called quadratic is because of the x squared term over there. In this video, I'll be going over some new features of quadratic equations compared to linear equations, followed with some examples. Methods of solving them will be done in a separate video. Up till now, you're probably used to solving linear equations, where the highest power of x is 1, like the following: x plus 5 equals 11, and 3/4 of x plus 15 equals 150. Just rearrange the equations, right? Find the value of x. Easy. In solving these equations, we are actually answering questions such as: there is a football team with 5 players in it. How many additional players are needed for there to be 11 players in total? Or, I had 150 ringgit in my wallet and need at least 15 to spend on my lunch. Now I'm going to buy some clothes from the store, which will give me a 25% discount on any product I buy because I am a member. What is the highest pre-discount price I can afford? When we talk about quadratic equations, we are trying to do the same thing, which is to find the value of the unknown x which satisfies that equation. There are two distinct differences though. Firstly, it's in the type of questions we are trying to answer. Consider the following. If you drop a ball off a ledge 100 meters high, how long will it take to hit the ground? Or maybe consider a problem about population. Consider the country of India, whose population is 1.35 billion as of 2018. If its government targets the population to be 1.5 billion in 2020, 2 years from now, what rate must the population grow at over the 2 years to achieve that goal? Basically, we have to solve 1.5 equals to 1.35 times x squared. And note, if you go for a 3-year period, it becomes a cubic equation, and for an n-year period, it becomes an n polynomial. The last example I have here is an example from farming, and this was actually the OG problem that led the ancient Babylonians to find ways to solve quadratic equations. Alright, imagine a Babylonian farmer who works on a square plot of land. He grows A crops every meter of land, so if his field is x meters long, its area is x squared, and he produces ax squared amount of crops. But the problem comes when the emperor comes and demands 1/4 of all his crops as taxes for using the emperor's land. Yep, they had taxes at the time. If he needs to sell C crops in order to make a profit, what should the length of his farm be? Now, our farmer has to solve ax squared minus 1/4 ax squared equals c. As you can see, the type of questions you can answer by knowing how to solve quadratic equations are more complex than linear equations, which highlights just how important it is to learn them. The second difference between quadratic and linear equations is that the way we find our unknown x is very different. It's not just about rearranging. Just try solving x squared plus 2x plus 1 equals 0. Go on, I'll give you a second. We can try rearranging it, move the 1 over to the other side, factorize the x maybe. You can keep trying, but nothing like that is gonna work. In fact, we'll be learning 4 different methods of solving quadratic equations: factorization, using the sums and products of roots, completing the square, and using the quadratic formula. I know what you're thinking, 4 sounds like a lot, but don't worry. At this level, they are all interchangeable, so you only really need to know 1 or 2 methods that you're comfortable with. I won't be covering that here, so if you want to find out more, tune in to my next video. That's all for today. I've included a link with some more interesting applications of quadratic equations in real life down below for those who are interested. Remember to stay curious and always follow your dreams. I'll see you in my next video.